What a beautiful day it is. All right, head count. Where is baby Morris? I think he's been cow-napped.
Have no fear, the AP Cow Squad is here.
Golly gee, thank you, Donis.
No problem, ma'am. That's what we're here for. By using simple theorems of calculus, we've solved crimes worldwide. Isaac Newton didn't create calculus for nothing because we're the COWculus detective.
Good luck!
Need some faster wheels if we're gonna save Morris. Don't worry, I got this. But how do we get in? Math, Sherlock. Find the slope of the line tangent to x squared plus 4x plus 2 at x equals 2, x equals 3, and x equals 4.
First, you have to differentiate the equation to find the slope of the tangent line. Then, you plug in x equals 2, x equals 3, and x equals 4. Now, we have the code.
So what's the code, Sherlock?
8, 10, 12.
We're in! The car knows where to go, but it looks like we need a code.
If we calculate this equation, we can find the coordinates of the cow. Ellie put a tracker on it.
First, we have to integrate. And now we have to evaluate. God. Let me stop. This equals 20 over 3, which is the same as 6.6 repeating. And to find the y-coordinate, we have to integrate again. And then evaluate. This equals 68 over 3, which is the same as 26.3 repeating. We got our coordinates. 6.6 repeating and 22.3 repeating.
All right, Watson, plug them in.
All right, 6.6 and 21.6.
Let's go! Okay, this is where the GPS led us. But now what?
Sherlock, I see something on the ground.
Let's check it out! What is it?
Looks like a collar to me.
It's Morris the cows!
Is that a fingerprint I see? Because yes, that's possible.
We can run it through the scanner to get an ID.
Let's do it! Let's get this cow napper. Okay, we're in. Let's go.
for the finger scanner to work, we need to plug in the positive and negative equations for the circle with the radiuses 2, 3, and 4. The equation for a circle is y equals the square root of r squared minus x squared. So if we plug in y equals the square root of 2 squared minus x squared, y equals negative square root of 2 squared minus x squared, y equals square root of 3 squared minus x squared, y equals negative square root of 3 squared minus x squared, and y equals square root of 4 squared minus x squared, and finally y equals the negative square root of 4 squared minus x squared, we can get a fingerprint that looks like this. Perfect.
Got him.
Great.
I'll put the fingerprint in the identification server, but looks like we need to solve a puzzle first. The computer gave us this problem in order to get in. Air is being pumped into a spherical balloon at a rate of 5 centimeters cubed per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters. So we know the volume is 4/3 pi r cubed, and volume V prime would be 4 pi r squared r prime, and then we plug in what we know and we get r prime is 0.039. I recognize this guy. Looks like he lives at 2 Marketplace.
Alright, you got me. Oh, there's one more puzzle you have to solve. The acceleration that the Prius must drive is given by the equation AFT equals 60 minus 1/2 t. If the cow is 6 minutes away, find the velocity at which the Prius must drive.
Alright, we'll solve it, but you're coming with us.
Get in the car, you villain!
Got him! So here's the problem that the villain gave to us to solve to find out how fast we have to drive to get to where the cow is. The acceleration that the cowmobile must drive is given by the equation A of t equals 60 minus 1/2 t. If the cow is 6 minutes away, find the velocity at which the Prius must drive. If this is the equation, then first we have to integrate it from 6 to 0. When you integrate 10 minus 1/4 t, you get 10t minus 1/4 t squared. And we're trying to find this equation from 6 to 0. So 10 times 6 minus 1/4 of 6 squared minus 10 times 0 minus 1/4 of 0 squared, which gets 60 minus 9 minus 0. So we'll have to drive at 51 miles per hour for 6 minutes in order to find Morris.
Thank you so much, calculus detectives. You have rescued my baby Morris, and look at him now, happy as a clam.